In this session, we will discuss about questions related to empirical and molecular formula, stoichiometry related questions, limiting reagent, mass percentage, and the expected KCET questions from this chapter. A sample with composition 40% carbon, 6.7% hydrogen, and 53.3% oxygen had a molar mass of 60 gram mole inverse. Find the empirical formula and also the molecular formula. There are 7 steps involved to solve these kind of questions. We will deal with them one by one. In the step 1, we should convert each percentage to gram. For this, we will assume the total mass of the compound to be 100 gram, and it is given that the composition of carbon is 40%. This means that the mass of the carbon out of the total 100 is 40 gram, and similarly hydrogen is 6.7 gram and oxygen is 53.3 gram. The second step is to divide the mass of each element by its standard atomic mass. In the case of carbon, it is 40 divided by 12 and the answer is 3.3333. In case of hydrogen, it is 6.7 divided by 1 and the answer is 6.7. And in the case of oxygen, it is 53.3 divided by 16 and the answer is 3.3312. In the third step, we should find the smallest number out of these three numbers and should divide each of these numbers by the smallest number. Here we can see that 3.3312 is the smallest number, and we will divide the three numbers by 3.3312, and the answers are 1.006 for carbon, 2.011 for hydrogen, and 1 for oxygen. The fourth step is to round these numbers and write the empirical formula using these numbers as subscript. So we will get the empirical formula as CH2O. In the fifth step, use the empirical formula you have just found to find its molar mass. In the case of CH2O, the molar mass is 30 gram mole inverse. The sixth step is to divide the given molar mass in the question, that is 60 gram mole inverse, by the molar mass of the empirical formula, that is CH2O, to get the value of N. That is, N is given by the given molar mass divided by the empirical formula molar mass. So the value of N is given by 60 gram mole inverse divided by 30 gram mole inverse, and that is equal to 2. The seventh step is to multiply the empirical formula by the value of N. Here in this case, the empirical formula CH2O is multiplied by 2, and we will get the molecular formula as C2H4O2. Next question is to find the empirical formula of a compound that contains 80% carbon and 20% hydrogen. The first step is to convert the percentage to grams, and it is 80 gram for carbon and 20 gram for hydrogen. The second step is to divide the mass of each element by its standard atomic mass, that is 80 divided by 12 equal to 6.666 for carbon and 20 divided by 1, that is equal to 20 for hydrogen. The third step is to find the smallest number among these two numbers, and it is 6.666, and we should divide each of these numbers by 6.666, and we will get the answer as 1 for carbon and 3 for hydrogen. Using these numbers as subscript, in the step 4 we should write the empirical formula, and we will get the empirical formula as CH3. Third question, a compound was found to have a composition of 2% for hydrogen, 32.7% for sulfur, and 65.3% for oxygen. Find its empirical formula. The first step is to convert the percentage to grams. In the second step, we should divide each of the elements by its standard atomic mass, and we will get the answers as 2 for hydrogen, 1.02187 for sulfur, and 4.08125 for oxygen. In the third step, we will find the smallest number among these three numbers, that is 1.02187, and divide each of these three numbers by 1.02187, and we will get the answers as 1.957 for hydrogen, 1 for sulfur, and 3.9939 for oxygen. In the fourth step, we should round these numbers and write the empirical formula using these numbers as subscript. For hydrogen, the value 1.957 can be rounded to 2, and for oxygen, 3.9939 can be rounded to 4. So the empirical formula of the compound is H2SO4, and that is sulfuric acid. We will deal with one more question. A compound contains 4.07% hydrogen, 24.27% carbon, and 71.65% chlorine. Its molar mass is 98.96. Calculate the empirical formula and molecular formula. This is the most easiest way of solving these kind of questions. First, the values of percentage composition and atomic mass are written down. In the next step, the percentage composition is divided by the atomic mass of the element, and we will get the answers as 4.07 for hydrogen, 2.02 for carbon, and 2.018 for chlorine. Now, the smallest number among these three is 2.018, and we should divide each of these three numbers by 2.018. And after rounding the answers, we get the relative ratio as 2 for hydrogen, 1 for carbon, and 1 for chlorine. So the empirical formula is CH2Cl. Now we should find the value of N. N is given by molar mass divided by empirical formula mass. And it is given in the question that the molar mass of the compound is 98.96. The empirical formula mass of CH2Cl is 49.5. Dividing these values, we get the answer as N equal to 2. Now we know that molecular formula is given by N into empirical formula, that is 2 into CH2Cl, and we will get the molecular formula as C2H4Cl2. Now we will discuss some questions related to stoichiometry of the equation. The question is, calculate the amount of water produced by combustion of 16 gram methane. The equation for combustion of methane is given by CH4 plus 2O2 gives CO2 plus 2H2O. That is, 1 mole of methane combines with 2 moles of oxygen to form 1 mole of carbon dioxide and 2 moles of water. In this question, the compounds under consideration are methane and water. The relative ratio between the number of moles of methane and water is 1:2. This means that 1 mole of methane after combustion produces 2 moles of water. The next step is to find the number of moles of methane as per the details given in the question. The number of moles of methane is given by mass of methane divided by molar mass of methane, and that is equal to 16 by 16 and is equal to 1. Now we know that if 1 mole of methane undergoes combustion, according to the balanced chemical equation, 2 moles of water should be produced. So the number of moles of water produced here is 2. From the number of moles of water, it is very easy to find the amount of water produced. It is given by number of moles of water into molar mass of water, that is equal to 2 into 18, and the answer is 36 gram per mole. The next question is, calculate the amount of water produced by combustion of 32 gram methane. Now we know that 1 mole of methane undergoes combustion and form 2 moles of water. Now we should find the number of moles of methane as per the details given in the question. The number of moles of methane is given by mass of methane, that is equal to 32 divided by molar mass of methane, that is 16, and the number of moles is 2. We know that 1 mole of methane produces 2 moles of water. So as per stoichiometry, 2 moles of methane will produce 4 moles of water. So the amount of water produced is given by number of moles into molar mass of water, that is 4 into 18, and the answer is 72 gram per mole. The next question is to calculate the amount of carbon dioxide produced by combustion of 32 gram methane. From the balanced chemical equation, it is very clear that the relative ratio between the number of moles of methane and carbon dioxide is the same. That means 1 mole of methane produces 1 mole of carbon dioxide. Now we should find the number of moles of methane as per the details given in the question. It is given that 32 gram of methane undergoes combustion. So the number of moles of methane is given by 32 divided by molar mass of methane, that is 16, and the number of moles is 2. Now we know that since the relative ratio between the number of moles are the same, 1 mole of methane produces 1 mole of carbon dioxide. Similarly, 2 moles of methane will produce 2 moles of carbon dioxide. Now the amount of carbon dioxide produced is given by number of moles of carbon dioxide into molar mass of carbon dioxide, that is equal to 2 into 44, and the answer is 88 gram per mole. As a homework, calculate the amount of carbon dioxide produced by the combustion of 64 gram methane. Next we will discuss about limiting reagent. The reagent that is entirely used up in a reaction is called limiting reagent. The limiting reagents are substances that are completely consumed in the completion of a chemical reaction. They are also referred to as limiting agents or limiting reactants. If 56 gram of nitrogen is mixed with 8 gram of hydrogen to form ammonia, which is the limiting reagent in this reaction? The balanced chemical equation for the Haber process, that is for the production of ammonia, is given by N2 plus 3H2 gives 2NH3. This means that 1 mole of nitrogen combines with 3 moles of hydrogen to produce 2 moles of ammonia. Thus, for 1 mole of nitrogen, 3 moles of hydrogen are required. Similarly, for 2 moles of nitrogen, 6 moles of hydrogen are required. Now we will find the number of moles of nitrogen and hydrogen as per the details given in the question. The mass of nitrogen is 56 and the molar mass of nitrogen molecule is 28. So the number of moles of nitrogen is given by 56 divided by 28 and that is equal to 2. The mass of hydrogen is given as 8 and the molar mass of hydrogen molecule is 2. So the number of moles of hydrogen is given by 8 divided by 2 and that is equal to 4. Actually, for 2 moles of nitrogen, 6 moles of hydrogen are required. But as per the details given here, only 4 moles of hydrogen are present. This means that hydrogen is less in amount and thus hydrogen is the limiting reagent in this question. Next question. If 56 gram of nitrogen is mixed with 16 gram of hydrogen to form ammonia, which is the limiting reagent in this reaction? We already know that the relative ratio between the number of moles of nitrogen and hydrogen is 1:3. This means that for 1 mole of nitrogen, 3 moles of hydrogen are required. Similarly, for 2 moles of nitrogen, 6 moles of hydrogen are required. Now we will find the number of moles of nitrogen and hydrogen. Number of moles of nitrogen is given by 56 divided by 28, that is equal to 2. And the number of moles of hydrogen is given by 16 divided by 2 and that is equal to 8. We know that only 6 moles of hydrogen is required to completely react with 2 moles of nitrogen. But in this case, the number of moles of hydrogen is 8 and the number of moles of nitrogen is 2. This means that hydrogen is more in amount and nitrogen is less in amount, and thus nitrogen is the limiting reagent in this question. Now we will discuss about mass percentage. Mass percentage of an element is given by mass of the element in the compound divided by molar mass of the compound into 100. As an example, we will now find the mass percentage of hydrogen and oxygen in water. We know that the molar mass of water is 18 and the mass percentage of hydrogen is given by 2 divided by 18 into 100, that is equal to 11.11%, and the mass percentage of oxygen is 16 divided by 18 into 100, that is 88.89%.